Okay, so continuing to point 4, so this question says, find the intersection of the two planes. Is the intersection a point, a line, or a plane? So it's asking us to solve the system, but just wording it in a different way. Okay, so same question. So we just need to find the intersection or the solution to the system. And I should have switched the two around like I did in the last example, but we can do that now. So if we have the 1, we can switch row 1 with row 2. This is smaller to solve because it's only 2 equations, so we don't need to make as many zeros. We make a 1, we make a 0. Make a 1, make a 0. All right, so what's the next step? Which number needs to change? The 2. That's in row 2. It's a positive 2, so the 1 needs to be a negative 2. So negative 2 times row 1. Plus row 2. So that's a nice new row 2, because you can see that it's all divisible by 5. So our next step, so we made the 1 and the 0. We go to row 2. The first number we come to, we need to be a 1, so that's in row 2. The only option to make a 1 here is to divide by whatever number is there. There's no row below it. We're dividing by negative 5. And then what? So we made our 1. That needs to be a 0. So that's in row 1. It's a 1, so the lead one needs to be negative 1. So negative 1 times row 2 plus row 1. So negative row 2 plus row 1. That's our new row 1. We didn't change row 2. And what next? That's it. Right? So you make a 1 in the first row and then zeros, 1 in the second row, zeros. There's no third row, so you stop. Doesn't matter what everything else is. So the letters, or the variables that were in our equation were x, y, z, so we're going to use the same ones here. So this will be x, y, z. This is a lead, because it has a lead 1. Lead, because it has a lead 1. And this does not have a lead 1, so this is our free variable. We'll call it t. And we write out our system. So our first row gives us x equals 1. Our second row gives us y minus 2z equals negative 4. And z we're going to let be t. So y minus 2t equals negative 4, and solve for y. So our solution has to say x equals, y equals, z equals. Z was going to be t. X is just 1, and y we rearranged and put the t in. So minus 4 plus 2t. Is this a line, a point, or a plane? A line. One direction vector. Okay, so what's the point? 1, -4, 0. And t, there's none for the x1, 2, and 1. Okay. So the intersection of a plane. So we did that before, or they asked you to do them earlier in the chapter before you could row reduce, and that was when we were trying to do it with in R3, and it gets complicated. So this sort of keeps it all together. Okay, so I wrote the next question out. So we've got a big 3 by 4 matrix there. And part A just says write the system of equations. So it didn't give us the variables, but we know how many variables there are by the number of columns. So there's 4, so we'll say x1, x2, x3, x4. So if we write the first equation, we would have what? So part A. So minus 2x1 plus 4x2. No x3, so just skip it, and 5x4. And what would that be equal to? Minus 15. The second row gives us, starts at x3, so 3x2, 12 minus 12x3 minus 7x4 equals, and then our second number, which is a 2. And our third also starts at x2, 1x2 minus 4x3, there's no x4s, equals -1. Okay, so that's all question 1 asks. So write out the system. B is also write out the system, but it's asking for it in AX equals B form, so what would that look like? Minus 2, 4, 0, 5. Okay. X are variables. They would be x1, x2, x3, x4. And our B is minus 15 to minus 1. You know, it looks like this should only have 3, but be careful. That's why I wrote this one first. If you only wrote 3, what's wrong with that? Right, they don't line up, because when you multiply the row by the column. So that would mean minus 2x1, 4x2, 0x3, and 5. Right, so be careful of that. And in fact, when you find your solution, you could just do a matrix multiplication and see if you get the right answer. Instead of actually plugging it in like we did, you could do the multiplication. That would be another way to check. And C says what? Write this system as a linear combination of the column vectors of A. So the column vectors of A, well, here's A. The first column is minus 2, 0, 0. The next column, 4, 3, 1. So it's saying write a linear combination of the column vectors of A. So what might that look like? Now my question is, are A, B, C, D just x1, x2, x3, x4? Are these the x1 terms? Are these the x2 terms? Yes. So the linear combination would be so there's three ways to write a system, and asking to solve a system, whether they look like A, B, or C, is all the same thing. Okay, so they could be different ways to write a system. Now, D says use row reduction. I'm not actually going to go through the row reduction, because I did enough of them. I'm going to give you the answer. Okay, so D, what I'm going to give you is this is how it would be on, like, not on this test because I'm making you actually do it, but on the final exam, because in Chapter 3 you have to row reduce everything as well. So I don't need to, on the final exam, closed book, I don't need you to spend like hours just row reducing. So on most of the questions I give you the answer. I do get you to do it once or twice, like for an inverse N1 system, but the rest of them where you would need it, I give you the row reduction, and then you can use that for something else. So this is what that looks like. Did I miss a row there? Oh, I missed I missed the answer, which we do want on there. And I need to find my actual answer somewhere here. So if you have a pencil, you could write that in. So this should have had the minus 15. It's not going to look nice here. Minus 15, 2, minus 1. I forgot to put that on. The other thing, if you're practicing at home, there are applications online. You just search row reduction calculator. You can put the original matrix in and it'll give you the answer. And then you can check if you've row reduced it correctly. Quick like that. I used to do that when I first started teaching, because I would solve them all to see if they work. I figured out later that there's actually quicker ways to do it by starting with a solution and just working backwards to something. But at first, I just wrote a random matrix when I was making up questions and then solved it all. So I would use the computer to just spit out the answer. Now, there are calculators online that will actually show you the row reduction steps, but they don't do it in the same order, 1 and then zeros. Like, they kind of look around, and if two rows both have 2's in them, they'll add those or subtract those. So I wouldn't look at their exact steps because they'll make it all confusing. It's a computer. They don't care if they go in circles, right? They don't mind not doing it all in the right order. They just go by whatever someone programmed into it. So you can look at them, but it probably won't be exactly the way that you're trying to do it. They would definitely not switch rows to avoid fractions, because the computer could care less if it has fractions or not, right? So, you know, they're not doing it sort of the same way as us. All right, so if we know the row reduction, how do we solve the system? Just like I did at the very first of this chapter, this section, I wrote out the row reduction, and you just took it out and wrote the solution. So that's all we're going to do. So this was x1, x2, x3, x4. So we'll just write the solution. So which are the free variables and which are the lead variables? So lead, lead, and lead. So X3 is free, right? So you look for the ones that are the starting ones in each row. So because there are 3 rows that don't all have zeros, then there's 3 lead ones. And then we would write it out. So X1 minus 8X3 equals 12. The second row gives me X2 minus 4X3 equals 2. X4 equals 3. So put your T in. Two plus 4T. And then you'd write out your solution. X1, X2, X3, X4. So X1 is 12 plus 8T and 2 plus 4T. You could write it in vector form. The question didn't specifically say it, so you wouldn't necessarily have to. This is also the, it's parametric form. It is the solution. I've been writing them all in vector form just to show you how to do it, because we're going to have to use the vector form later. Okay, so the next question. Okay, so we've got a system. One of the ones on the homework has an A, B, and C in it, so it's got 3 letters. So you just have to be really careful, and you're going to row reduce with that letter in it. That's what you're going to do. So we want to find out what A would have to be for it to have different types of solutions. So you would write your system. 1, 1, 2, 1. 3, minus 1, minus 2, 3, and put an A right in it. And then if you add rows that have A, if you add 3 plus A, then that would be 3 plus A. You just leave it like that. So we row reduce the exact same way. So there's a 1 in the top corner. Okay, and we want these to be zeros. So you'd start the same way. So row 2, if that's a positive 3, so this needs to be a negative 3. Negative 3, row 1, plus row 2. And for row 3, that's a negative 1, so that needs to be a positive 1. It already is. So row 1 plus row 3. So minus 3, row 1. Plus row 2, 0, minus 4, minus 8, 0. Row 1 plus row 3. Zero, 4, 8, A plus 1, or 1 plus A. We just add them. And the missing number doesn't have to be on the right-hand side. It could be anywhere in the matrix. Okay. So, what next? This 4 needs to be a 1. So we'll divide that row by negative 4. All right. Now, we're concerned here with what's happening with A, because we're worried about A. What does A have to be for this to work? So you can keep going in the normal way by making these 2 zeros. But really, I'm just going to worry about the 4, because I'm going to make that one a 0 first and see what happens. Okay? You can just make them both zeros. So to make row 1 a 0, we're not trying to solve the system, we're just looking for A. But to make 1 a 0, we would say that's a 1, so this needs to be a negative 1. So negative row 2 plus row 1. And row 3, that's a 4, so this would need to be a negative 4 plus row 3. I'm just going to do this step first. Negative 4 row 2. And adding it to row 3. Zero, 0, 0, A plus 1. Okay. So I didn't even do that because you're concerned with what's going to happen at the bottom, or wherever the A is, really. So, for this to have no solution, what would have to happen here? So we've got to lead 1 for the X, we've got to lead 1 for the Y, and here's the Z. It's going to be free because there's a 0 here, right? Do you see that? But this would have to be a what for it to have infinitely many solutions? Yeah. For infinitely many solutions, that last row would have to be all zeros. Or else it has no solution. Because you can't have zeros and then a number. So for it to be all zeros, A plus 1 would have to equal 0. So A would have to equal negative 1. So that's for infinitely many solutions. What about no solution? For no solution, that last row would have to look like this. Like all zeros, which it already is, and then a number. Not 0. Right? So we would say A plus 1 if it wasn't 0. So if A was not negative 1, then there'd be no solution. What about one solution? It's not possible. What would have to have happened for it to be possible? To have one solution. You have to have a lead variable for each X for for the y, and for the z. We can't make a 1 into a 0, so it's not possible to have a 1 there, so then that would be it's not possible to have one solution, so that would be... So I'm going to write down the system and row reduce it to show you what it would look like. And there's a couple of these to practice on the homework. All right, so I would try them. But basically, when you set this one up, how many variables are there? X, Y, Z, there's 3. So X, no Y, 1 Z. 2x minus 1, 0. 0, 1, 2. And A, B, C, 3. Okay. So right away, anything you do with row 4 has A, B, C in it. Let's just start one step to show you. So, what would our first step be? This is already a 1, so we'd make these into zeros. That one's already a 0, so that's good. So this one's in row 2. It's a positive 2, that would need to be a negative 2. And this one is in row 4. It's an A, so what would the 1 have to be? Negative A. So minus A row 1 plus row 4. So if you did that, minus A row 1 is multiplying minus A by everything in row 1. So minus A, 0, minus A, and A. Plus row 4. 0, B, C minus A, and A plus 3. Okay, weird, I know. I'm just going to do this step and write it out. You can trust that I have it right. If I copy it right. Lines get off a bit. Okay, what would we do next? Can you see what's going to happen, first of all? Do you look at row 2 and row 3? Yeah, you could change them or change the signs. I mean, we don't even really need to show that. Just go through and change the signs, because you're going to rewrite it, the whole thing, just for that, right? So that needs to be a 1. So we could interchange these two. But what about these two rows? They're the same. So what's going to happen when we make the 0? One row is going to be all zeros, because they're going to, yeah. So we need to make this a negative, right? We need to do that, but we also need to make these into zeros, okay? So just in the interest of notes and not skipping steps, I'm going to write it, but you could just go through and change these signs. You wouldn't get that marked wrong, because you're still on the right track. It's not, I don't necessarily even look through that you rewrote everything, but I'm going to do it just to make sure my answer's complete. Okay, so we've made that into a 1. These need to be zeros. So this one's in row 3. It's a 1. That needs to be a negative 1. And row 4. All right, so what about row 4? That's a B. The 1 would have to be a negative B. So negative B, row 2, plus row 4. All right, so you would multiply everything in row 2 by negative B. And add that to row 4. And these are getting more complicated. So C minus A minus 2B, 4B plus A plus 3. All right, what next? Well, rows of zeros have to be at the bottom, so it'd be good to switch that. All right, I'm not going to rewrite that right now. But we can stop, because what we're looking for is what A, B, C, D to get one solution, no solution. Okay? I said I wasn't going to rewrite it, but I'm going to. C minus A minus 2B, 4B plus A plus 3. There we go. Okay, so for it to have one solution, what has to happen here? We'd have to have a 1 right here. We have to have so for one solution we've got our X, Y, Z, and we need a lead 1 for each of them so that we can read off the answer. This is a row of zeros. It tells us nothing, so we can just ignore it. But for one solution, C minus A minus 2B would have to, not 1, because if it was a 2, what would we do? Divide that row by 2 and then make it a 1. So it doesn't have to be a 1, it just has to be not 0, because then you can't make a 0 into a 1. So it can't be 0. And, I mean, you don't even need to do anything with that. You just say C minus A minus 2B can't be 0. So whatever, there's lots of options that we could plug in there. We could give one example, but essentially, as long as that is not 0, we could make it into a 1. So that would be one solution. Let's go with the no solution next. What would have to happen? Maybe infinitely. Well, I don't know. Neither one of them is easier than the other. So what do you think for this? No solution. What has to happen in that row? No, not both 0, but for no solution, this would have to be 0, and that would have to not be a 0. Right, so for no solution you need zeros and then a number. So there would be two conditions. You would say, okay, for no solution, C minus A minus 2B would have to equal 0, and 4B plus A plus 3 would have to be not 0, any other number, because then we would have zeros and then a number. And then what about infinitely many? We need a free variable, so we have X as a lead 1, Y as a lead 1. We don't want Z as a lead 1, so we would want this to be a 0. but this would also have to be 0, so that it wouldn't be no solution. So these both have to be 0. So if we had 2 rows of zeros, that's okay. And you don't actually need to find the numbers.
So if I combine those?
You could combine these here. This is a bit trickier, so I just wouldn't combine them anywhere. Yeah. And like I said, there's a couple of these to try on the homework. Okay, so you can see, you can try it, and the row reduction part is the part because they get kind of tricky to write. And really, don't be concerned with anything above it. You're really looking for that last row, because that last row either is all zeros, would be infinitely many solutions, a number, and this doesn't matter because that could be a 0, because then Z can equal 0 is okay. But you can't have zeros and then a number. So you just look for those cases. Okay, so that's the end of 2.6, and then we're going to start, or 2.4, and so we'll do 2.6, which is very short.